any other time we see square brackets, it's going to be the index. So we're trying to get one element in the array. But the first time that we have these square brackets when we define the array, that's just saying what the size is. Yep. So if we wanted to define a variable, such as the planet variable like we did on Friday, that would just be string planet without the square brackets. But if we wanted to do an array of planets, string planets, in the square brackets, you put the size of the array. So in this case, if this was going to store 8 planets, we would put the number 8 inside there. Yep. Okay. Array initialization. So it would be slow if we just defined it with 8 planets and then we had to say planet 0 is this, planet 1 is this. So in C++, we have a way to add all the elements in the array right when we define it, like an initialization statement. And in this case, like 25 would go into index 0, 9 would go into index 1, 18 would go into index 2. Comparing that to variable initialization, we can do that with variables too. So when you define a variable, you can immediately assign a value to it. That's essentially what we're doing with the arrays as well. One thing I still see when people are defining string arrays, they're leaving off the quotes. You only leave off the quotes if you actually have a variable called Venus. Otherwise, if you want it to be equal to like the word Venus, the word Earth, the word Mars, you need to include the double quotes. Yep. Okay. And then final slide we had on arrays was modification. So we could initialize the values 25, 9, and 18, but then we can go back and change those values. Essentially, when we have like this ages of 1, this is now treated exactly like a variable. Anything we can do with a variable, we can do with one element of an array. So we can assign new values to it. So we can assign 12 to this ages of 1. So this 9 would change to a 12. You can also use it on both sides of the equal sign. So in this bottom line, what's happening? Does the right side or left side evaluate first? Right side, what's the current value of ages of 2? 18. So we're doing 18 plus 3, 21. So that's like saying ages of 2 is equal to 21. Yep. So the 9 would change to a 12. The 18 would change to a 21. Yep. All right. Kahoot with some candy on the line this time. Playing for some bragging rights and some prizes. Kahoot here, go to kahoot.it, and the game code. $592,167. I think one more. All right, let's do it. Cool. And actually, I realized I forgot to put the semicolon on here, so that was my bad. But thank you for still marking it. Yes, so string restaurants 8. Why was it not string restaurants 7 here? Yeah, if we were talking about index, then 7 would give us the last element because we start counting from 0. But when we're defining it and we're doing it with size, we use the number. Sweet. Okay. Initialize an array with 2 restaurant names. Okay, what's the difference between the blue and the yellow? Yeah, so if we're trying to do it with the names, we want the quotes there. Otherwise, I would think it was variables. And in this case, we might not have variables. Yep. All right. All right. what values are stored in nums? Take your time with this one. All right, so let's see it. Okay, so we start off with 5, 3, and 2. What happens after line 8? Yeah, so nums 1 is this one here, so we have 5, 4, 2. So then what happens on line 9? 4 plus 2 is 6, so we now have 6, 4, 2. And then what happens at the last line?
2 plus 1.
Yep, so then we have 6, 4, 3. A little bit harder when you don't have scratch paper. So I would encourage you, especially like there will be some problem like this on the exam. When you're doing it on the exam, kind of just have some scratch paper, write out what the array looks like after each line. Yep. Any questions here? Okay. All right, close at the top. What values are stored in nums? All right. Nice work, everyone. Spot on. If we actually wanted to swap the numbers and make it 3, 5, 2, what would we have had to have done? Yeah, so we would have needed a temp variable to store nums of 0 so that before we overwrite it on line 8, we don't like lose that data. Yeah, so in this case, the problem was trying to switch them, but it just made it 3, 3, 2. Cool. All right, last problem. And then a poll. What is the error in this code, if any? Five more seconds. Okay. So we do want this problem to print out 10. So let's... Okay, first off is the initialization okay, starting the index at 0. Yeah, because we want to start with the 0th element, which would be 5. So that's fine. Is the condition okay? Index less than or equal to 3? No. What's wrong with it?
It should be index is less than 3.
Yeah, so this array just has index 0 is 5, index 1 is 3, index 2 is 2. There's no index 3. If we ran this code, some would give us some random value. Because index, when we try to say nums of 3, it's going to give us some random value. The danger with C++ is that they don't do what we call bounds checking with arrays. So especially if we were trying to write a value, nums of index, and we were trying to say nums of 3 is equal to something, you could crash your computer because the computer hasn't set aside that many elements for the array. So you might be rewriting some random memory location that is actually doing something very critical. And it's the reason why C++ doesn't do bounds checking is it makes it faster, but it can lead to really devastating errors. So this is what we call an off by one error. Generally, we always do index less than the length of the array, not less than or equal to the length of the array. Yep. Cool. All right, final poll. How do you feel about arrays? Okay, cool. All right, let's see podium. In third place, Sandro. Ready? Oh, all right. Kedar. Oh, my bad. And Aaron. If you don't like your piece, you can switch it out at the end of class as well. We have Twix, Musketeers, Milky Way, Snickers. Cool. Okay. So let's get into new topics now. Parallel strings. In homework 8, even if you've done this problem in homework 8, hopefully this will still help to explain the reasoning behind it. We have three variables in this problem. 4 variables, I guess. So we have our answer variable. So if the puzzle, the answer was dad. We have our puzzle variable where initially they're all just going to be dashes, and as we guess letters correctly, the dashes are going to change. We have our letter variable. So in this function, whoever's calling the function might be trying to guess the letter D. Okay? So first off, just in English, I guess first off, what should the puzzle update to if we're trying to check if the letter D is in this puzzle? Yeah, like we would want this, like these two indexes match up. So we would want this to change to a D, we would want this to be a blank, and then we would want this to be a D. Everyone follows what the goal of this function is? Okay. So first off, we know that the index, like we need to check every element and answer. So what does that mean we need to do in order to get all these indexes? What structure can we use?
For loop.
Yeah, a for loop. So we essentially need a for loop to get all these indexes. So the for loop that you've already done a ton in lab and that you're going to continue to do, for index equals 0, index plus equals 1, index less than the length of the array. By the end of this class, you'll have written that exact for loop probably 100 times, right? Because that's what helps us get every element in an array. So we get this first element in answer. How do we get this element in answer? This D, how do we get it?
Like answer index.
Answer index. So the first time when index is 0, that would give us answer 0, which is D, right? So what is the if statement that we want to check in order to know whether we need to do anything to the puzzle?
Puzzle index equal answer.
So not quite puzzle, because right now puzzle of index is going to be a dash, so that's never going to be equal to the letter.
Yes equals equal.
Yeah, so let's just call this variable like letter. So how can we set it up in terms of those variable names?
If the letter is equal to answer index.
Yes. So if this letter is equal to answer of index, then we know we need to update the puzzle in some way. Right? So let's just get what we've said so far. So let's set this up as a function. So what would the return type be for this?
Char.
So we'll have it be a string. So we update the puzzle, and the puzzle is a string, and then we want to return that string back. So we'll have it be a string. What parameters? Essentially, what data did we need here?
The answer in the letter.
Yeah, so, oh, shoot. So we need the letter. What data type is the letter going to be? Char. So we're going to need a char letter. What else do we need?
Puzzle.
Yeah, we need the string puzzle. And then what else do we need? Index, but we can define that inside of the function. Like, we know that's always going to start at 0, so we don't need to ask for it. What do we need to ask for? We have the letter, we have the puzzle.
Yes.
Yeah, we need the answer. So in here, we're returning a string, and we need three things. We need the letter that's been guessed. We need the puzzle so that we can update it, so that we can return the updated puzzle. And then we need the answer, because we need something to check against. If we didn't know what the answer was, we wouldn't know how to update the puzzle. So is everyone good with defining the function? Okay. So then we said in our for loop, because we want to get every index, we would have int index equals 0. I guess what would our condition be if you haven't seen the slide? We want this to work for any length answer.
So it'd be answer dot length.
Yeah, so we want index to be less than answer.length. When we work with arrays, it's often similar. We say like, well, index is less than the array size. With strings, we're saying index is less than the length of the string. Yep. And then index plus equals 1. So both with strings and arrays, we're going to be using this for loop, this exact for loop a lot. We have index equal to 0. We have it go less than the length. Okay? Then we said in our if statement, can we just repeat what it was?
If letter.
Yeah, so let's forget guess. Like, we're using everything in terms of letter. So,
Letter equals, what was it? Also,
Letter equals puzzle index.
so letter's never going to equal puzzle index, because puzzle is just going to be these dashes.
Letter equals answer.
Yeah, so if letter equals answer of index, if letter equals answer of index, what do we need to do to the puzzle?
Then you do like answer index is equal to letter.
Oh, the puzzle index.
Oh, yeah.
Yeah, because so answer of index is already equal to the letter, so we don't need to change answer at all. Inside of this if statement, we're updating the puzzle. How does it know to update the correct index here? This is the key to parallel strings. How does it know, in the example with dad, how does it know to update puzzle of 0 and puzzle of 2?
Because it's the same letter.
Yeah, like the way this parallel structure works, this 0 index is being shared by both the answer and the puzzle. So right here, like the first time the loop runs, index is 0. And we're checking, does letter equal answer of 0, which is D. And if it is, then we update puzzle of index, and index is still 0. So we're saying puzzle of 0 is equal to D. Then in the next iteration, index is 1. And we check, does letter equal answer of 1? Is that going to be true or false?
False.
That's going to be false. So we don't have to do any update. And then we have index equal to 2. And we check, does letter equal answer of 2? Yes. So then we update puzzle of 2 to be equal to D. So that's how we get both these D's to come in the puzzle. And we didn't do anything when the index was 1, because it didn't match answer of 1. Do people follow? And then what do we return at the end of the function?
Puzzle index.
Puzzle index will just return one letter.
Or just puzzle, right?
Yeah, just puzzle. So we've updated puzzle, so now we might have D blank D, and so then we can return that. And now we have an updated puzzle. Yeah? All right. I maybe see some confused faces. Are there any questions? Everyone good? Okay. So characteristics of parallel strings. Both strings need to be the same length. And essentially there has to be some relationship between like the string 1 of index and string 2 of index. So in our case, like string 1 was answer, string 2 was puzzle. And the relationship between answer of index and puzzle of index is that they should ultimately match. Like if we knew letter was equal to answer of index, we want to update that same index in puzzle. That was the relationship there. Why do both strings need to be the same length for parallel string problems?
Because when you call them for the index, if it's like an extra index, it's not gonna like count that letter. It's not gonna be none to match it.
Yeah, exactly. Like in this example here, if puzzle is only 2 elements long, then when we check if letter equals answer of index here, we won't be able to do any corresponding calculation here for puzzle. So there has to be like a relationship between every element, between the first string and the second string. And then what we do in the for loop is some sort of, that's kind of the hard part, is like figuring out that relationship. But once you figure out the relationship, this is the general concept. Yeah? Okay, so if we were to test our code that we wrote before, but this time we're going to do it with the letter A. So the first thing we said, index equals 0. We check if letter equals answer of index. So letter is A. Does letter equal answer of index here? No, so we don't do anything. We just increase index by 1. Now, does letter equal answer of index? Yes, it does. So we said if it does, then puzzle of index equals letter. What's the value of index right now? 1. So we're saying puzzle of 1 is equal to A. So this dash here is going to change to an A. Then we go to index of 2. We say does letter equal answer of 2? No, so we don't do anything. So in this case, our updated puzzle would be blank A blank. Yeah? All right, people feel good to do this homework problem themselves? How is homework A? Do people have general questions on anything in there? It's okay? All right, we'll have office hours today from 3 to 5? Yeah.
There was the leak code.
Yeah.
Yeah, that was one of the problems I struggled with.
Okay, we can take a look after class during office hours. We can see. Yep. Okay. Parallel arrays. All right, can anyone guess what characteristics are of parallel arrays?
The array has to be the same length.
Yep, both arrays, or we can do it with multiple arrays too. So all the arrays need to be the same length. And then what's the other characteristic?
There has to be some sort of relationship in the array.
Yep, some relationship between like each index in the array. So in this case, I just said array 1 and array 2. You could even have more arrays than this. Okay, so let's say we wanted to do a problem where we calculate multiple rectangle areas. So we had done a problem where we just calculated the area of one rectangle. And what did we say the formula is to calculate the area of a rectangle?
Length on side.
Yeah, length. Yeah, you could be height or I'll call it width. So length times width. That would help us calculate the area for one rectangle. But let's say we wanted to calculate the area of 3 rectangles. We could have 3 lengths and we could have 3 widths. And what would the relationship be between like this array and this array at each index?
Maybe the first array times is that array. Like, that
Yeah, we could kind of consider this, like these two values to be related to rectangle 0. These two values could be related to rectangle 1. These two values could be related to rectangle 2. So for each of them, if we wanted to calculate the area of a rectangle, it would be like length of 0 times width of 0. Right, so do people follow what the relationship is here between these two arrays? Okay. Okay. So in groups, I'll have you write this code out. We're gonna have our 2 arrays, lengths and widths, and we want to store each of the values in an areas array. So John, here. Yeah, you do it together, and then Freddie, if you're okay joining us with helping here.
What do you want us to do?
So we want to fill out this areas array. So by the end of this problem, the areas array should have the areas of 3 rectangles. Wait, do you can join under these groups here. Yep, so that would give us the area of the 0th rectangle. Yeah, so we want to generalize it with a for loop.
Oh, I didn't even see that.
Oh, so like you just have like
Or so it's that initialize index into index, and then make the condition index is less than 3. And then update it with binary. Yeah, you do. You gotta count.
and then it would pretty much just be so we have to like multiply each array
Array dot.
like like 0 multiple zero, that or 2, like, you know what I mean? I understand. So we can just be like area index.
So yeah.
It's like what is it? Length index width index.
Yes, but instead of doing it all in zeros,
Right.
how can we generalize
Yeah, that would
this,
work.
every time? Yeah.
Because then if we set the index plus 4, then the next time it does. So first it was 3 times 2. Yeah. Plus 1 for the index.
Oh, we went
times
times
4. Yeah. And then what you use return array.
We want to subtract 3?
We don't need to print it out, we just need to update the areas. At the end, area should
Like areas index equal yeah, but there's no
Okay. I think people are on the right track, so we'll come together. So essentially here we were saying, like, how would we get the area of this first rectangle? Or the 0th rectangle, I guess.
it's length of 0 times width of 0.
Yeah, so we essentially have 3 times 2 to get 6. And then if we wanted to get the area of this rectangle, it would be lengths of 1 times widths of 1. And then this rectangle would be lengths of 2 times widths of 2. So it's always the same formula. The only thing that's changing is that index subscript. So that's our clue that we can do this in a for loop. So what goes in the for loop?
Index equals 0.
Yep.
Index is less than 3.
Mm-hmm.
Index plus equals 1.
Yeah, so again, this is going to be our standard array for loop that we write for most problems where we want to get every element in the array. And the benefit now is, normally we would only do this just to get the elements of one array. Now we're going to use it to get the elements of 3 arrays, all using the same index. So areas of index, that's how we're going to populate the different values of areas. Areas of index, and what do we want that to be equal to?
Length of index times width of index.
Yeah, so lengths of index times widths of index, right? So this is the power of parallel arrays. We can use the same index variable everywhere, and that makes sure, like, first we do these 2 elements, then we do these 2 elements, then we do these 2 elements, and their products all get stored in the appropriate bucket in areas. Yeah? Any questions here? Okay. For homework 9 that I'll release later tonight, one of the problems is going to be an exam grading question where you'll have like your answers array with different multiple choice answers, and then you'll have a guesses array with each guess for each of those questions. And that's going to be a parallel arrays problem where the guess at index 0, we need to check if that's equal to the answer at index 0. So we just use one index variable, but we get to check multiple elements in the different arrays. Yep. All right. So again, characteristics of parallel arrays. All arrays need to be the same length. So in this case, the problem wouldn't have worked if, let's say we didn't have like a value here, right? If this was just a 2-element array, then we would have said like lengths of index times widths of index, so 3 times 2, lengths of index times widths of index, and then here once index became 2, we would have had lengths of 2 times widths of 2, which would have been some random value. So we need them to be the same length, otherwise this doesn't work. So the arrays have to be the same length, and there needs to be a relationship between each of the arrays. Yeah. To this code here. So in this case, we have a relationship between the areas array, the lengths array, and the widths array. And the relationship is that each index represents one rectangle. Yeah. So if we wanted to, after this code, yeah, we could have another for loop that outs each element in areas. Yeah, we can't just do, with arrays, if you were just to do this, like out areas, does anyone know what this would print out?
It prints out all three.
It would not.
It's print out the first index, right?
It wouldn't print out the first index either. It would print out the memory location of areas. So when defining arrays, it's given like a memory location. So if this was like our array, it would just print out this memory location 1,000.
So you'd have to put the brackets after it, or?
If we wanted to print out every element in areas, yeah, we would have to create like another for loop and say index equals 0, index less than 3, index plus equals 1, and then out areas index to print out each element in areas.
So without the CO, it'll still print out the array of areas?
Like right now without this out, it won't actually, this won't print anything. This is just like, we have all the values stored in areas and we can do whatever we want with it later. Like if we want to print it out later in the code, we can. If we wanted to like double the size of all of the areas, we could go and do that later too.
Put a return at for loop to make it print out the areas or not?
Return statements are only if this was like some other function and we wanted to return it back to main. Yeah. Yeah. Essentially to print out the elements of an array, and we do it in lab. So if you haven't come into lab yet, today's the last day for lab 9, make sure you come in. That's where we talk about like printing items in an array. Cool. Okay, I think people are generally on the right track with parallel arrays and parallel strings. They both act very similarly. We'll have more practice on the homework that I'm releasing tonight. Okay, one final thing I wanted to say. Like I've kind of hinted at it. This like string looks very similar to an array, right? What kind of array would this be if we wanted to represent this as an array? Like what data type array would it be?
Char.
Yeah, a string can also be represented as a char array. So if we had in our EdStem here, let's go into Scratchpad 3. We've often said like string word equals like hello. You could also do it like a char word 2 with 5 letters is equal to hello. And they both actually get stored in memory exactly the same way. Yeah.
But don't chars need single quotes? Or would it matter if you're just doing it?
So yeah, the other way we could define it as like char word 3.
And then the single quotes with the letters in the
Yeah, so then we do it with like this initialization, and then we'd have like H, E, L, L, O. This statement is essentially converting it under the hood to this. Yeah. Part of the reason why we spent so long on strings and doing string traversal is that under the hood, they are almost identical to arrays. It's almost like a char array, essentially. Yeah, like just like a fun fact, you don't need to like memorize this, but it might help to think about like why they're so similar. Is that under the hood, strings do get stored like char arrays. Cool. All right. So I'll give people some time to fill this out right now if they're interested. So one is going to be homework parties. A lot of people came last Monday, 3 to 5 to office hours. That's great. If you haven't finished homework 8, come in today from 3 to 5. But we also want to give more working time like that earlier in the week, as opposed to leaving kind of the last Monday office hours. So if you're interested in just coming in like an hour a week, I really think if you come into one homework party for an hour, you can pretty much finish the homework if you have that in-person support. So when I tell my friends, like, why don't people come in and get that support? And they're like, oh, like some students are like, they don't like the inertia to come in. It does save you time, I think, in the long run to come in and get help. Or this is the link. So I'm giving people time now to fill it out if you're interested. bit.ly/homework-party. Just fill it out if you're actually interested and you think you would actually come to them, because I'm going to try to choose times that work for the most interested students. And then on the other end of the spectrum, if you feel like everything in the class is going super well, you feel very confident, you want more challenging problems, and you want to do more stuff with interviews, fill out this bottom link here. And they're both just asking generally what your schedule is like and what time you would want to come in. So I'll give people like 3 or 4 minutes to fill those out if you're interested. You don't have to put in a password. I think it's optional. Just put in your name and then you should be able to fill it in.
Once you fill it in, we don't need to enter anything. We can just fill it in.
Yeah, and I think there's just like a submit button, so your times get saved on that link. And if you feel like you work better by yourself, no obligation to fill it out. Like only if you think you would actually find it helpful. The other thing for people that are interested, you can scan this QR code. This event's going to happen tomorrow night. I'm going to give general tips for interviews, what interviews look like, kind of give interview 101. On the homeworks, I'm starting to give practice interview questions as well, but I think this talk will actually go into more detail about what it would look like. I'll give people 1 more minute to fill them out. And then final thing, homework 8 due tonight. We'll have office hours today from 3 to 5. Come in if you haven't finished it yet. And then lab 9. I think there was more attendance on Friday, but I think half the class still hasn't finished lab 9. So if you haven't finished lab 9, make sure you come in today at 5 p.m. Yeah? Cool. Also, I wasn't good about throwing out candy in class, but you can take a piece on your way out. Just note the Snickers have peanuts in it. I think all the other candies are fine, but the Snickers have peanuts, so if you're allergic, yeah, don't take the Snickers. And the people who won the Kahoot can take 1 extra piece, so that's your prize there. Yep.
Lab at 5.
Yep, lab at 5. Yeah. You good with peanuts, yeah?
So,
You okay with peanuts?
Yeah.
Okay.
Can I come in at 4 for the lab? Because I've been meeting at 5.
Yep. Cool. Okay.
this website is weird, but into me,
Is it like not loading properly?
no, I mean, it is, but like, I don't know what to do next. Once I filled it in.
Okay, so those are the times you're available.
Mhm.
Okay. Then I think